MTA, midterm assessment. Alright, I will include from topic 1 until topic 5 lah, until what you've learned today. Okay, so I have already put up the lecture notes for part 2 available in the Teams, as well as the tutorial number 5. Okay, so let me share the screen first. Actually saya tak biasa sangat guna yang apa browser ni. Mana? Okay, can you see the monitor clearly? I mean, not monitor, the screen.
Yes, Doctor.
Okay, alright. Okay, alright. So let us do exercise number 5. Okay, so before this, I already discussed previous exercise. Okay, this one is the direct one lah because it only involve a liquid phase. Okay, so there's no problem lah, tak ada macam it's a direct calculation je lah. But for exercise number 5, it involve gas phase. Okay, so mari kita tengok. Okay. Okay. Okay, so the irreversible gas phase non-elementary reactions, okay, is given in the below equation. We have a 2A plus 2B equal to C. Okay, so this is gas. Okay, remember this is gas. Is to be carried out isothermally in a constant pressure batch reactor. Okay, so it is a batch reactor. The feed is at temperature, this is T0, 227 degrees Celsius, and the pressure is 1013 kPa. Okay, so this is a P0, and its composition is 33.38% and 60.7% of B. Okay, so automatically this would be the YA0 and this would be the YB0. Okay, so it is given the value of the negative RA at X equals to 0. Okay, at conversion equal to 0, the negative RA value is given here. Okay, so below in this question also, it provides you also the table for the value of the RA with X. Okay, so this is the value. Okay, so what you need to do is how you relate this value with the volume. Okay, so you have to refer back to the design equation. Okay, so you have a design equation for the PFR and also VCSDR. Okay, so okay, kita try dulu, tengok dulu. Okay, so let's see, we have a look at the question A first. Estimate the volume of a plug flow reactor, which is PFR, required to achieve 30%. Okay, conversion of A for entering volumetric flow rate. Okay, so this is the value for the V0. Okay, the small V0. Alright, so what you need to do, okay, tengok dulu here. Okay, okay, so for A, okay, so V PFR, if is equal to X, okay, to 0 ataupun X2 to X1 ke, okay, terpulang. Alright, FA0 dx over negative RA. Okay, so you have to look at the value, the question given. Okay, so did I give you what is YA0, what is, what is T0, what is P0. Okay, so from here automatically you boleh sebenarnya dapat what is CA0. Okay, remember what is CA0? CA0 is equals to YA0 P over RT. Okay, so that's why bila ada semua information you extract dia keluar so that you know which value you need to calculate first. Okay, and how do you manipulate this equation to fit with the information given. Okay, so just put the value which is 0.33, okay, and then times with P over RT0. Alright, you should have the value of 0.08311 gram mole over decimeter cube. Okay, so this is the value. Alright, so once you get the value, what you need to do, how you relate CA0 with this equation. Alright. So automatically you know that we can get another in term of the tau, which is okay. Expand dulu lah, which is FA0, and then we have a negative RA, okay, dx over negative RA. Okay, so what is FA0 is CA0 V0, alright, and then we have a F dx over negative RA. Okay, so this is VPFR lah. Okay, so from here, what you can do is you can get in term of tau, okay, which is tau is equals to VPFR over with the V0, okay, and then equals to CA0 F dx over minus RA. Okay, so here you can use the constant value which is CA0 here. Okay, and dx over negative RA actually is a function of the RA, is the function of RA with x. Okay, remember before this we have a table which is in terms of RA. Okay, RA here. Okay, and then we have a x also here. Okay, we have a x here. So given this is 0.01 and then 0.0 0.05, and then we have 0.02 and 0.01. Okay, so x here is 0, and then we have a 0.2, okay, and then 0.4 and then 0.6. Okay, so this one in terms of 10 to the power of 3. Okay, so bila awak letak dia RA kat bawah, dia akan jadi minus. Okay, that's why tadi ditulis kat situ x equal to 0 is equals to RA is equal to 0.0001. Okay, sebab kalau awak letak 10 kuasa 3 bawah, dia akan jadi 10 to the power of minus 3. Okay, so here what we can do is we try to get this one. Okay, which is CA0 over negative RA. Okay, so just put it, okay, awak kena bahagikan lah. So setiap ni you kena bahagikan dengan 0.0831 bahagikan dengan setiap RA. Okay, so you'll be able to get this value lah. So for example, this one is 188,112.77 and then 16225.54. Alright, 0.54 and so on. Try to kira lah. Okay, so daripada situ sepatutnya you kena ada graph lah. You construct a graph. Okay, sebab graph ni sama je. Dia boleh guna untuk PFR, dia boleh juga untuk CSR. It's just that bila you masukkan equation, kena guna equation yang according to the type of the rector. Okay, so this is CA0 over with the negative RA, and then we have X here. Okay, so plotnya lebih kurang macam ni lah you akan dapat. So at certain point you akan dapat lah this one is 0.01, okay, and then 0.005 and so on. Okay, yang ni dia dah start ke atas sebab dia dah bagi x equal to 0, dia dah ada value this one. Okay, alright, so ni akan dapat besar lah, 8,000, 16,000 and so on. Okay, so daripada situ you kena dapat 0.3 to 0. Okay, so daripada situ awak kena dapat point dekat conversion adalah dekat 0.3. Okay, so dekat sini tak ada kan. So you kena sebenarnya bila you buat graph ni, you boleh estimate lah 0.3 kat mana. Okay, katakan this is 0.2, this is 0.4. So you just extrapolate. Okay, so dapatlah sini. Okay, so this one is untuk mewakili 0.3. So you have what is CA0 negative RA dekat x equal to 0.3. Okay, so from here approximately is around 4664.84 second. Okay, so this is for this value. Okay, so how you relate with the volume is VPFR now is equals to this one times V, naikkan atas lah, times with the V0 here. Okay, So we know is given is around 2 meter cube per minute. Okay, that's why it's better for you to write down the unit, all right, in each of the equations so that you know which one to cancel. Okay, so from here you need to convert lah from second to the minute, which is we have 1 minute is equal to over 60 second. Okay, so times with the 1 minute or with the 60 second. Okay, so from here you will get the value of the volume, which is around 155 1 15.155.5 meter cube. Okay, so this would be the answer. Okay, so faham ke up till this one? Okay, everyone?
Okay, madam.
Okay, doktor.
Okay, alright. So jangan letak dekat mind setting, which is kalau untuk cari nama dia untuk volume, perlu ini kena guna information yang biasa yang kita guna. Tak semestinya. Okay, which is this one darab terus dengan FA naught, okay, times with the X over negative RA kan. Okay, tak semestinya. Kadang-kadang ikut pada soalan yang diberi. Okay, so kalau dia bagi CA naught, bolehlah terus guna yang macam ni. Okay, sebab ni macam mana you dapat ni pun sebenarnya you belajar dekat chapter 4 yang ada area of the area under the curve. So macam mana kalau ini ada in term of tau, area akan jadi in term of tau. Ingat tak yang saya pernah tunjukkan lah. Okay, dia akan darab X darab dengan Y is equal dengan adalah benda dia. Okay, so refer balik kat situ. Okay, so semua apa yang awak belajar ni awak kena relate lah dengan topik yang sebelum ni. Okay, so for B, okay, saya akan tunjuk CSCR dengan ni je lah, dengan contoh PFR dan CSCR. Pakai yang lain awak try buat, saya bagi final answer je. Okay, so for this one, untuk B, kita tengok balik soalan. Estimate the volume of CSCR required to take the effluent from the plug flow reactor above and achieve 50% total conversion based on species A to the PFR. Okay, means that sekarang ni kita ada PFR, which is connect to CSCR. Okay. Alright. So ini PFR, ni CSCR. So sekarang ni yang kita kira tadi adalah between 0 to 30% conversion. So kita akan starting X1 ni kat sini adalah 30% to X2. Okay. Alamak sorry ya, bising sikit sebab anak saya dekat atas sebab bawah ada cleaner tengah bersihkan rumah saya. So di atas ni dia agak bising sikit. Okay, itulah challenge untuk bekerja dari rumah ni dengan anak kecil. Okay, so daripada situ, okay, you buat, okay, which is, alright, which is VSTR is equal to FA naught X over dengan negatif RA. Sekarang RA2 lah sebab kita ke second reactor. Okay, so this one jangan lupa kena tukarkan dia. Okay, which is FA naught times with the X2 minus with the X1. Okay, bawah still sama. Okay, and then we have VCSTR here. Okay, so this one also you can expandkan dia, which is defined as C naught V naught. Alright, so bawakan dia ke bawah. You akan dapat tau is equal to VCSTR over V naught equals to C naught times with the X2 minus X1. Over with negative RA2. RA2 should be dekat X equal to 0.5. Okay. So daripada sini, you kena tahulah what is CA0 ni. Okay. Yang ni tak perlu nak buat ada integration lah sebab ni adalah CSCR adalah dalam algebraic form. Okay. So you kena tahu plot sebab dia ada between 0.4 to 0.6 kan. So you tak tahu 0.5 CN0 over RA dia berapa. So you kena tengok dekat graph yang you plot tu. Agak-agak lah 0.5 sini berapa pula kat sini. Okay. So this one you akan dapat around what do you call it, you kena darab juga dengan X2 minus X1, jangan lupa, which is 0.5 minus which is 0.3. Okay, so jawapan lebih kurang 12,169.2. Okay, second. Okay, and then you need to get the VCSR, okay, using the same like this one, which is VCSR is equals to what do you call it, V naught darab dengan benda ni lah. So this one darab dengan V naught, okay, which is 2 meter cube over mean. Okay, jangan lupa lah ni tukarkan dia daripada 1 minute per 60 second. Okay, so you akan dapat around 5.64. Sekejap bateri dia nak mati. Okay. Alright, okay. Faham up to this part?
Faham, Doktor.
Okay, alright. Thank you for the response. Okay, so try buat yang lain. Okay, so total volume ni, yang number C ni you can dapat total volume. So apa yang you dapat daripada volume A dengan B tambahkan je lah. Okay, so you will have this volume. Alright, so this one kita tak boleh nak buat 80% conversion sebab limit dia sampai 0.6 je. Okay, sebab graph tu you tak boleh nak extrapolate dah sebab dia maksimum dia adalah dekat 0.6. Yang you boleh extrapolate kalau yang lower than that lah. Ni kita tak tahu berapa, dia tak tepat. Kita tak tahu 0.7 dekat mana 0.8. Okay, so dia akan valid sampai kira sampai 60% sahaja. Okay, so this one jawapannya dalam 561. Mana pemadam ni? Alamak. Okay. Ni lah. This one dalam 561.1 meter cube. Okay. And this one dalam 1014.1 meter cube. Okay. And then we have this one dalam 270.4 meter cube. Okay, so this is the answer. Okay, so you kena plot rate of reaction and conversion as a function of PFR. So you kena buat lah, this is PFR, it should be under the curve. So this one is RA, ikut je soalan dia nak, RA versus dengan V. Okay, you kena try buat plot dia macam mana bentuk. Lepas tu lagi satu adalah X versus with the V. Okay, so setiap kali awak dapat X berbeza, volume akan berbeza. Okay, guna je maklumat yang ada kat situ. Just you manipulate in term of X ni. Okay, yang ni pula you boleh dapat lah terus which is kira balik volume untuk setiap ni lah. Untuk setiap ni. So you boleh dapat lah a few points here. Okay, RA dia lah berdasar yang ni lah. Macam tu je. Alright, so kena plot lah. Alright. Okay. Okay, so this is one of the subtopic for part 1, which is reaction dump collar number. Okay, saya pun tak sempat study siapa dump collar ni. Alright. Okay, so DA is equal to negative RA naught V over FA naught. Okay, tengok dulu macam mana boleh dapat DA ni. Okay, so is equal to rate of reaction at entrance. Okay, and then entering flow rate of A. Okay, so kalau flow ni mesti dia berkaitan dengan convection. Apa yang the one that you belajar macam mass transfer, heat transfer tu lah. Okay, so the dot then collar is the dimensionless number. Okay, the unitless lah that can give us a quick estimate of the degree of conversion that can be achieved in continuous flow reactor. Okay, daripada sini kita boleh tahulah sama ada dia give approximately this one lah dia punya indicator. Kalau DA ni less than 0.1 means that it will usually give less than 10% conversion. Kalau DA punya number here which is more than 10%, dia akan will greater than 90%. Okay, so macam mana kita dapat DA number ni? Okay, so let me show you first. Sekejap saya tambah satu slide, senang tulis. Okay, alright, so let's see we have a saya besarkan. Okay, so let's say we have a V is equals to FA naught times with the X over negative RA. Okay, so daripada sini we know that we can expand the equation. Okay, let's say this is a irreversible reaction which involve A to B. Okay, so this is first order lah, which is negative RA is equal to KCA. Okay, so FA naught, we can expand the FA naught becoming CA naught V naught times with the X over with this one. Okay, so what is CA is equal to KCA naught 1 minus X. Okay, so this one is KCA naught 1 minus X. Okay, so from here, we can cancel the CA naught, all right, and it become rearrange it at one side, which is V naught, okay, and then we have a K here, okay, is equals to X1 minus X. Okay, so what is dA actually? Okay, so this one, remember V over V naught is tau K is equal to 1 minus X. Okay, so this one actually is defined with the dA. Okay, so it becomes dA is equal to X1 minus X. Alright, ataupun if you want to make it as a tau K, so tau K here, I sambung sini, dK kan sama, dA is equal to tau K is equal to 1 minus X. Alright, so rearrange kan supaya kita nak dapatkan in term of X, then you will have X is equals to I padamlah dulu ataupun letak dalam dA dulu lah untuk senangkan. Okay, so this one we have a dA dengan ni lah X over ni. So we have a dA minus X dA is equal to X. Alright, dA X1 plus. Okay, then rearrangekan dia, kita akan dapat X is equal to dA, 1 plus dA. Okay, so what is dA? dA is defined as tau K. So you letak je lah tau K 1 plus with the tau K. Alright, so this is for the what do you call it? First order reaction, which is this one lah. Okay, ni I dah simplifykan lah, buatkan this one. Okay, so you will have this. Alright. So if for second order, nanti kita buat soalan tu lah jap. Okay, so sebenarnya saya dah derivekan lah untuk soalan ni. Okay, derive ni dah cukup. Okay, ni boleh masukkan balik lah. Okay, so tengok pada number 2. So a second order reaction A to product. Okay, so sekarang ni dia adalah second order reaction. Okay, which involve negative RA is equal to KCA squared. Is conducted in the 2 liter constant volume CSCR. Okay, so this is a V. Okay, the initial molar flow rate and the initial reactant concentration is given. So this is the FA naught. Okay, and this is the CA naught. Okay, the reaction rate constant is 2 liter per mole second. Okay, so this would be the K. Okay, the rate constant. Assess whether the reaction is able to provide good conversion. Okay, remember there's an indicator. Kalau dA dia lebih 10 means that usually give greater than 90% conversion. Kalau dA dia less than 0.1, consider as a not a good conversion lah. Okay, so oh sorry. Sekejap. Alright. Okay. So from here, just refer back to the what is V. So V is equals to FA naught X over RE. Okay, so V is equal to FA naught X KCA naught K1 minus X equals to 2. Okay, so just again just change it atau convert into CA naught and V naught. So it becomes CA naught V naught times with the X. Okay, KCA naught 1 minus X squared. Okay, so this is V. Okay, just ni, so tinggalkan dia automatically, which is V over V naught, alright, times with the K. So what remain here is K is equal, X is equal to divided by CA naught. Oopsie. Oh. K1 minus X squared. Okay. So from here, you can directly masukkan lah untuk dapatkan DA tu apa. Alright, ataupun you boleh jugalah cari what is X. Okay, so for example, you can get the DA. Okay, automatically this is a DA lah. So this is tau. So DA is equals to tau K is equal to X. Alright, CA not, ni CA, sorry tulisan 1 minus X2. Okay, tapi problem is dia tak given the X. Okay, so what you can do is masukkan dia balik semula. Okay, which is we have a V or V naught K equals to X K CA naught 1 minus X squared. Okay, so CA naught tu dia bagi 4, K dia beri value is 2, this one 2 and this one 6. Okay, so you kena try dapatlah what is X. So disebabkan ada kuasa 2 ni, so you kena guna ni lah. Sorry for this. Okay. Alright, so you boleh dapat X tu baru you boleh masukkan balik nilai dia. Sini tengok DA dia apa value dia. Okay, just masukkan sini. Okay, kalau DA lebih daripada 10 means that is in a good conversion. Okay. Alright, faham ke? Up till now?
Faham, doktor.
Okay, so we have another part which is the last part lah, part number 2. Sikit je dia punya slide, 12 slide sahaja. 12, lebih kurang lah kot. 16 macam tu lah. Okay, so you want a break or you just want to continue?
Continue, doktor.
Okay,
Continue.
Alright, okay. So, okay, sekarang ni part 1 you learn about the multiple reactors. Now you learn about complex kinetics. Okay. Okay. So this is complex kinetics means that we will learn about reversible. Okay, there is a forward and there is a reverse reaction. Okay, and you also learn about autocatalytic reaction. Okay, akan terangkanlah tips. Oh, ada tekan salah. Sekejap ni. Ya Allah, ni MTA salah ni. I remove dulu ni. Okay, MTA tak tahu pun lagi bila. Okay, so we will cover this one lah, reversible reaction and autocatalytic reaction. Okay, so you need to know for point number 2 and also point number 3. Okay, yang ni you dah belajar lah tadi dekat part 1. Okay, so let's say we have a reversible reaction which involve the reactant of A plus B, okay, forming a product C and D. Okay, so you can see there are 2 arrows in the opposite direction. Okay, so this one usually we will name it as a forward. Yang ke depan ni forward. Alright, and we have another one we call as reverse. Okay, so benda ni boleh akan move forward, move reverse until they reach equilibrium. When once it reach the equilibrium, there is no forward or reverse lah. They akan remain as saturated lah. Okay, so from here, rate of consumption of A by forward reactions. Okay, so kalau forward reaction, kita tengok pada sini lah reactant. Remember kalau rate of flow memang akan tengok pada reactant sahaja. So dia akan jadi negatif RA forward. Okay, so that sekarang ni kita tumpu pada A plus B is equal to C plus with the D. Okay, so automatically negative RA forward is equal to K forward. Okay, so this is K forward times with the CA to the power of this one and CB to the power of B. Okay, number of the reaction ni, let's say it is according to the stochastic coefficient. Okay, so daripada situ we have another one, formation of A by reverse reaction. Okay, now we have a from C plus D, it becomes A plus B. Okay, so sebenarnya ini adalah dalam reverse. Okay, ni saya nak tunjukkan dia supaya you faham lah sebenarnya daripada produk tu balik, dia jadi balik reactant. Okay, so this one we consider as K reverse. Okay, so sekarang ni ini yang jadi reactant. Okay, just now untuk forward C and D become a product. Now when it in a reverse direction, it becomes what you call it as a reactant. So the red law should the red of reaction should be RA reverse. Okay, this is formation. Okay, so you should have this should be in term of positive. Okay, so beza dia dah sign dekat sini lah. Okay, so this one is K reverse CC times CD. Okay, to the power of the ni lah, order of fraction. Okay, so basically macam ni lah I akan tulis. This should be KF and this one should be K reverse. Okay, ataupun kita tulis KR lah. Ikutlah terpulang pada you. Okay, so net rate of A is equals to kena tambah dua-dua ni sekali summation of both of direction forward and the reverse. Okay, so the net of formation of any species is equal to its rate of formation in the forward direction. Okay, so formation of this one actually is equal to the formation dekat in the reverse pula. Okay, dia become ni pula. Okay, in the reverse direction. So the rate net would be this one. Okay, rate net is equal rate forward plus with the rate reverse. Okay, so basically this would determine the difference in term of the V. Okay, contohnya we have a V STR, so FA naught X over negative RA. Okay, so the negative RA you kena ikut pada ini kalau dia irreversible. Okay, reversible. So same like PFR. Okay, so this one also dia akan depends on the ni jugalah net of rate dia. Okay. Okay, so you just put it in the design equation here, R net. Okay, so we have another one, which is reversible reaction. Okay, this is the one that I've explained just now. Okay, so at equilibrium, here, okay, so RF will equals to RR. Okay, so if you can see, at one point, okay, let's say this is a product which is the C ataupun D lah, and then we have a A and B. Okay, so from here, the reactants, at terbalik. A atau B, this one C atau B. Okay. So time by time, if you can see, the reactant will be degraded. Okay, that's why dia akan makin kurang. Tapi the product will be formed, alright, when the time increases. Okay, so it will reach at plateau, okay, stagnant, okay, whereby there is no changing in the reactant and product. Okay, so this is what we call as it has reached equilibrium phase. Okay, so at equilibrium it will be continuously be at equilibrium. Okay, dia akan will be continuously at equilibrium. Alright, until we disturb the system, the equilibrium ataupun the system lah. Contohnya yang ni adalah exothermic. Okay, so which is dia akan keluarkan haba lah. Tapi bila you changekan dia, you supplykan haba, dia akan daripada produk tu dia akan form balik pada reactant. Okay, so bila you kacau the system in terms of temperature ke pressure ke apa ke, the equilibrium will be change lah. Alright, dia takkan akan ada static macam ni. Okay, so this is the one that belajar lah, apalah Chatelier principle. Okay, yang orang France yang buat tu lah, Chatelier principle. Okay. Alright, okay, so at equilibrium the net reaction rate is 0 for all species. Okay, so bila dia equilibrium, R A net ni is equal to 0. Okay, alright, nanti kita akan discuss macam mana bila RA net tu akan jadi 0. How about the RA forward and RA reverse. Asyik tekan salah je I. Tadi mana? Okay. So this is reversible reaction. So we have this one is KF and this one is the KR. Okay. So K is the red constant lah. Okay, so you jangan confuse. For K kecil ni adalah anak saya dah ni. Red constant. And then we have a K besar pula. Okay, K besar ni actually is equilibrium constant. So don't get confused between the capital and small letter lah. Okay, so this is for liquid gas. Liquid. Okay, alright, liquid ataupun gas pun applicable, but this one is only for gas lah sebab the pressure difference. Okay, so this one would be the product. Okay, remember this one is we got it from the RA. Okay, which is this is the negative RA untuk what do you call it, forward. Okay, and this one is RA for reverse. Okay, so this is the one that yang kita buat tadi lah, which is C. Kalau you nampak this one macam ni. Okay, it's just that instead of this one, we put it as CE, means that equilibrium. Okay, so inilah dia beza dia letak ni. Okay, dia ada E words dia. E apa? Inilah alphabet. Okay, so daripada situ, which is KC actually is equals to KF over with the KR. Okay, so kita boleh refer instead of KR ni boleh naikkan atas dia, KR is equals to KF over KC. Okay, nanti saya terangkan kenapa kita nak buat KF over KC. Kita nak letak reverse ni dalam term tu lah. Okay, nanti I will explain after this. Okay, so this one is for pressure pula. Okay, usually kita concentrate sini lah in term of concentration. Okay, so deriving KE in terms of XE. Okay, so XE is a conversion equilibrium. Okay, sorry ya kalau hari ni macam bising background I. Okay, so daripada sini, okay, automatically this is a okay, so we have a 2A is equal to B. Okay, so this is a second order of reaction. So become KC CB over CA squared. Okay, so this is the product over with the ni. Okay, sebab this is like KF KR. Okay, so 2A to B is the KF. Okay, and then we have a B to 2A is the KR. Okay, Sarah. Macam tu. Okay, so KC is equal to CB over CA squared. Okay, so KC is CB over CA squared untuk constant liquid phase. Okay, ni nanti akan derive after this ya. Next slide. This one. Okay, so from here, we have 2A is equal to B, means that A is equals to half B. Okay, so for liquid, okay, sekarang I want to derive it. So this one automatically is KC is equals to CB over CA squared. Okay, daripada situ, we need to know what is CA, what is CB. Okay, so CA here is equal to FA over with B. Okay, sekarang ni dia adalah constant, alright, constant flow. Okay, which is V akan equal to V naught. Okay, so daripada sini is equal to FA naught minus with the FA naught. Okay, now remember X sini dah tak ada X biasa, dia kena jadi XE. Okay, So this one times with the XE over with the V naught. Okay, so at the end it become FA naught over V naught K1 minus XE. Okay, alright. Okay, daripada situ matikan dia, jadikan dia CN naught 1 minus XE. Okay, so sekarang ni what is CB? Okay, CB is equal to FB over dengan ni. Okay, so remember FB daripada store commodity table, you will have FB naught plus with the half FA naught times the XA. Okay, over with the B naught. Okay, remember dulu yang kita buat ni, which is ada juga you buat, boleh juga FB is equals to theta B. Alright, kalau you nak dalam FA naught, so FA naught theta B plus with the half X. Okay, ataupun this one you boleh keluarkan lah sebab FA naught times theta B is equal to FB naught times with the times lah half, alright, FA naught times with the X. Okay, remember theta B is equal to FB naught over with the FA naught. Okay, so kalau FB naught ni lah darab. Okay, so daripada sini FB naught tak ada sebab dia dalam bentuk produk. Okay, so this one kita boleh cancel. Okay, so what remain is only this one. Okay, so it becomes half CA naught times with the XE. Okay, apa masalah? Aduh, lawaklah anak saya tu baring kat lantai merajuk dengan bapak ni. Okay, so daripada situ, okay, it become half CA naught XE. Okay, so faham ke until part this one?
Faham, Madam.
Okay. Okay, lepas tu so daripada sini we have just substitute what is CA and CB. Okay. Kejap tunggu jap kejap. Anak saya ni ya Allah, tunggu jap. Jap. Keep. Sat. Mana tadi? Okay, jap. Okay, sorry saya sorry ya tadi ada sikit ni lah interruption. Okay, semua ada lagi ke kat sini? Sorry.
Ada doktor.
Ada.
Ya Allah, sorry sangat-sangat ya. Aduh, hari ni memang anak saya. Okay, so saya dah tak, okay, saya sampai sini kan tadi. Okay. Okay. Saya share screen tak sekarang ni? Ke saya belum lagi share?
Dah.
Share.
Dah. Maaf lah kalau sikit. Okay, so daripada sini just masukkanlah what is CP. Oh, saya lupa nak ni. Okay. Sekejap. Okay, so daripada sini we have masukkan dia what is CB. So CB is half CA0 XE, okay, over with the which is the CA2. CA kita dapat ni kan tadi, okay, tapi jangan lupa dia kena kuasa 2. So means that this one is a CA0 kuasa 2, 1 minus XE kuasa 2. Okay, so you akan cancel, this one becomes CA0 sahajalah. That's why you akan dapat this one. Okay, so half ni turunkan ke bawah dia lah, which is this one, jadi 1.2. Okay, so you akan dapat this KC. Alright. Okay, saya rasa sekarang ni musim ni lah apa, tak berapa sihat. Okay, so sekarang ni let's say if we look at the gas phase, okay, macam mana kita boleh dapat this one. Okay, so daripada situ, this is gas phase, means that it has a variable volume. Okay, kita tulis ni adalah variable volume, which is V ni tak akan sama dengan V0. Okay, dia akan jadi sebenarnya V is equals to V0 1 plus epsilon X. Okay, so this is for gas phase. So Kc is equals to Cb over the Ca square. Okay, daripada situ kita carilah satu-satu what is Cb, what is Ca. Okay, so from here Ca is equals to Fa over V is equals to Fa0. Okay, yang ni saya dah pecahkan lah terus. Fa0 times with the Xe, okay, over with the V0 1 plus epsilon Xe. Okay, so daripada sini you boleh matikan ataupun keluarkan dia lah, this one as a Ca0. Okay, so daripada situ we have a Ca0 1 minus Xe, okay, over with the 1 plus epsilon Xe. Okay, so this is the answer lah. Okay, tahu kan yang ni kita keluarkan lah, this is Fa0 1 minus Xe. Okay, so bila awak keluarkan Fa0 over V0 ni akan jadi Ca0 lah. Okay, and then this one remain lah, and this one per dengan ni. Okay, so daripada sini we have a Cb, okay, is equal to Fb over with the V. Okay, remember B sekarang adalah dekat produk. Okay, jangan salah tau. So produk kena tambah. Okay, which is Fb0 plus with the half Fa0 macam sebelum ni. Okay, cuma perkan dia jadi lain, which is V0 1 plus epsilon Xe. Okay, so daripada situ ni akan jadi kosong lah sebab kita at T0 Fb tak ada, Fb0 tak ada. Okay, sebab dia produk. So what remain actually is half, okay, Fa0 Xe dengan ni. So this one kita boleh jadikan dia which is jadikan dia Ca0 lah. Okay, sebab Ca0 is equal to Fa0 over V0. Okay, so it becomes, okay, 2 kat bawah ni. Okay, so atas ni is a Ca0. Okay, and then we have a Xe. Alright, and then 1 plus epsilon Xe. Okay, so this would become the Cb. Okay, so So masukkan balik dalam ni. Okay, so what is CB? CB adalah half CA0 XE. Okay, masukkan balik yang ni lah over dengan this one. Okay, so mana CB? CB adalah CA0 XE over with the 2 plus dengan okay, so daripada situ and then 1 plus epsilon XE. Okay, ni untuk CB over with the CA this one which is CA naught. Okay, jadi kena kuasa 2 lah, which is 1 minus XE. Alright, 1 plus epsilon XE. Okay, kuasa 2. Okay, so bila you simplify, you akan dapat this one. Okay, faham? Okay, bawakan dia ke atas je. Yang ni perkan, naikkan dia ke atas lah. Which is we have a CA0 XE and then 2, 1 plus epsilon XE. Okay, naikkan lagi 2 ke atas ni. So terbalikkan dia, you akan dapat matikan dia lah. Alright, okay. So far okay ke up to that point?
Okay, madam.
Okay.
Boleh alright. Okay, so nanti you try lah rearrangekan dia. At the end memang you akan dapat ni lah yang tinggal. Okay, naikkan atas sahaja. Sini naikkan dia 1 plus epsilon XE. Okay, kuasakan dengan 2. Okay, and then this one CA0 kuasa 2. Then 1 epsilon XE kuasa 2. Okay, so that's why you akan ni tinggal ni macam atas lah. Lepas bawah ni CA0, ni dah tinggal ni CA0. Okay, and then this one. Okay, alright. Okay, so this would be the answer lah. Okay, now we have a reversible reaction. Example 1. Okay, we have a A to 2B. Alright, and then we have KRA. Okay, this is forward and this one is the reverse. Okay, so here KFA and KRA are the forward and reverse specific reaction where both defined with respect to A. Okay, so daripada sini what you need to do is you need to know what is RAF and RA reverse. Okay, right, let me show you. So the first thing you need to do is negative RA forward. Okay, remember sebab kita ada this one being degraded. Okay, so dia akan di negative. So is equals to KFA times with the CA. Okay, this is forward. Now kita tengok pada reverse. Reverse sekarang 2B ke A. Alright, this is KRA. Okay, means that dia akan form balik A. This should be positive. Okay, so positive is RE over R is equals to KRA times with the CB. Okay, remember sekarang ni adalah jadi reactants. Okay, so dia akan jadi macam tu lah. Okay, so daripada situ we know that KRA CB, jangan lupa sini kena letak kuasa 2. Oops. Okay. Alright. So the second thing what you need to do is what is RA net? Okay. So number 2 is RA net is equals to RAF plus with the RAR. Okay. So daripada situ what is RA? Okay, ambil je balik daripada sini. Okay. Is equals to negative. Okay, sebab sini nak positif, so kita balikkan lah jadi negatif ni. So negative KFA, okay, CA plus with the KRA. Okay, ni F, ni R ya. CB kuasa 2. Okay, so daripada sini yang kita nak ni adalah kita nak definekan dia. Instead of tak nak banyak tau ada reverse, kita nak guna just forward dengan KC. Sekarang kita nak relate K equilibrium ni lah, K constant ni dengan KFA. Okay, sebab kita nak guna reverse, nak guna satu saja. Sebab bila you nak kira dua tu nanti akan confuse. So better guna satu saja. Kita linkkan dengan KC. So if refresh, recall, KC is equal to KF over with the KR. Okay, so daripada sini kita tahu lah KRA is equals to KFA over with the KC. Okay, so daripada situ nombor 3, nombor 4, kira apa tu RA net. So RA net, okay, is equal benda ni kan, tapi you boleh keluarkan negatif ni. Instead of this one, kita put at this one. Sebab selalunya kita biasanya negatif RA is equal to KCA and dot. Okay, so better ni RA net letak kat luar negatif dia. So it become negative RA net. Okay, so ini akan jadi positif lah. Is equals to KFA CA, alright, plus with the KRA, ini minus, should be minus KRA CB kuasa 2. Okay, so remember kita nak replacekan ni sebab nak relate dengan KC. So it become KFA CA minus with the what is KRA? KRA here kan? So it become KFA over KC times with the CB squared. So keluarkan balik KFA dia. Okay, you boleh keluarkan KFA times with the CA minus with the CB squared over KC. Okay, so this is how you get lah this one. Okay, so bila at equilibrium, number 5 lah. Okay, so at equilibrium, remember as I told you before, negative RA net would become equals to 0. Okay, so this one is 0. Okay, so you just rearrangekan. Okay, then you will get this one. Sebab kalau ini dengan ni kan, kalau perkan 0 to KFA kosong kan. So this one akan jadi kosong lah. So yang tinggal is adalah, I tulis kat sebelah sini. 0 is equal to CA minus with CB kuasa 2 KC. Okay, so rearrangekan dia. Okay, sebab dia dekat equilibrium, so letaklah sini E, ni E. Alright, you buatlah, which is ni naikkan kat sini CB squared over KC is equal to CAE. Okay, so KC nak naik atas kan. So becoming KC is equal to CBE squared over with the CAE. Inilah cara dia nak dapat. Okay, faham kah? Is it clear to you?
Boleh, Doktor.
Boleh, Doktor.
Boleh Okay, bagus. Alright. Alhamdulillah. So kita pergi ke next one. Okay, tinggal lagi berapa slide je, sikit je ni. Okay. So for a reversible reaction A to B, what is the value of Kc if Ka is equal to 5 liter and K minus A 3 mean. Okay. So remember daripada Kc is equal to CCE over CDE. This is the forward. Okay. And this is the reverse. So we have a K forward over K reverse, kita dapat Kc. Okay, sebab remember Kc adalah equals to Kf over with the Kr. Okay, so this one should be Ka lah. This one should be K minus A. Sebab ini adalah Ka yang biasa. Okay, and this one is the K yang reverse. Okay, so automatically kita boleh 5 over 3, kita boleh dapatlah what is the value of the Kc. Okay, so the value is 1.67. Okay, and then let's say the question ask you about the size of reactor in case of reversible reaction, example CSTR. So you just write down the equation for the CSTR. Okay, remember this one, if it's in a reversible, means that it should be FA naught XE over the negative RE net here. Okay, so what is RA net? You kena ikut macam previous slide yang I tunjukkan you. Okay, which is negative RA net is equals to RA forward, okay, minus with the RA reverse. Okay, make sure you punya ni kena betul. Kalau you buat RA net sini positif, sini kena negatif, ni positif. Okay, tapi lebih elok kalau negatif kat RA net. Okay, yang I cakap tu lah ikut pada red law yang asal. Okay, so daripada situ you just masukkan lah. This is KA, A kan sini, CA minus with the, yang ni reverse lah. K minus A times with the CB. Okay, so masukkan value sini. Okay, and then dapat ni dapatlah nilai volume. Okay, volume. Tu dah I cakap dia punya volume punya equation still the same. It's just that RA ni akan jadi RA net lah untuk reversible. Okay, then we have an autocatalytic reaction. Special type of molecular catalyst in which one of the product, alright, sometimes reaction intermediates two of reaction act as the catalyst for the reaction. Okay, so this is autocatalytic reaction. Selalunya kalau apa nama dia, kalau kita guna reactor, dia jenis fixed bed reactor lah. Dia the bed reactor. Okay, BED, fixed bed reactor. Okay, so this one dia anggap we have a R as a catalyst. Okay, contohnya we have A, alright, is equals to R. Dia nak form a product of R. Tapi kadang-kadang ni R ni dia act as a catalyst. Means that dia akan juga jadi macam ni. Sama ada dia A is equal to R plus R. Okay, part of the catalyst dia akan jadi product juga. So dia akan jadi A towards to catalyst, at the same time dia akan produce juga product yang sama. Okay, which one of the product? Okay, this is one of the product lah. Okay, act as a catalyst, this is R. Okay, catalyst kan selalu duduk kat atas ni sebab sebenarnya catalyst ni dia tak mengganggu mass balance. Dia just as a macam ni cakap, dia as a untuk enhance the reaction sahaja. Okay, so kita tak kira dia berapa consume, berapa yang tinggal. Okay, dia macam inert lah. Okay, so inilah dia punya maksud saya dia punya konsep lah kalau senang nak ingat. Okay, dia guna tu R, tapi santai R tu pun akan jadi produk jugalah, dia jadi masuk ke bawah. Okay, so characteristic, the rate of autocatalytic reaction is low at the start, little product present. Okay, so dia akan start dengan very low, baru dia pergi ke high, lepas tu dia akan pergi low, nanti dia akan sebenarnya turun bawah balik. Okay, nanti saya akan explain after this. Okay, then rate increases as the concentration of catalytic product increases. Okay, so once you start utilize banyak catalyst, so product tu akan increase lah, dia akan membantu untuk formation of the product. So eventually goes through a maximum, dia akan pergi ke maximum, high kat sini maximum. Okay, and then lepas tu dia akan decrease balik bila reactant tu dah digunakan. Okay, mula-mula catalyst tu akan membantu untuk production formation. Lepas tu after catalyst tu dah tak ada tak very effective, so reactant pula digunakan untuk menghasilkan produk. So dia akan menurun balik lah. So example of this one lah, hydrolysis of an ester, okay, some microbial fermentation reaction and so on. Okay, so for example we have a HCOOH, okay, plus with the H2O2. Okay, so kita akan dapat HCOOH plus with the H2O. So ini macam this one is as a catalyst, so dia akan masuk part of the jadi product juga. Okay, for example we have another one which is HCOOH, alright, and then plus with, okay, ni masuk balik, plus with the PO. Alright, platinum oxide. Then we have dia pecah lah bond macam ni. Okay, so plus with dia ambil balik HCOH. COH. Alright, lebih kurang macam ni lah contohnya lah. Okay, so dia akan ada high rate and dia akan ada low rate. Okay, so daripada sini, okay, kalau nampak dia jadi produk kan, so dia akan jadi high rate dekat sini. Tiba-tiba produk ni dia akan guna the next reaction which is dia act as a reactant. Okay, that's why dia akan menurun balik kat sini sebab dia pergunakan. Okay, untuk jadikan produk lain. So dia menurun balik. Okay, faham tak?
Faham, Madam?
Faham.
Okay, dia macam dua proses lah. Satu dia akan jadi produk, lepas tu dia akan jadi reactant balik. Okay. Okay. Alright, okay. So, and then sikit je lagi dua je ni. Lagi tiga. So, in autocatalytic reaction, the rate is low at the start, little product present. Okay, dia macam ni lah. Bentuk macam ni. Dia akan low rate, and then it become high, and then when it reach the maximum here, okay, dia akan lower down back. Okay, once the reactant has been consumed. Okay, so rate increases to the maximum as the product increase and drop again as reactant is consumed. Okay, the one that I tunjuk tadi lah, ada contoh. Okay, so we have A to B and then KCA, CB. Okay, so this one is R versus with the C. Alright, C and not. Okay, so ini adalah C and not minus CA, sorry, C and not minus CA. Okay, so inilah dia punya ni. Okay, so bila dia reduce balik, dia guna reactant, contohnya CA sini kan, and then this is CA1, and then this is CA2, and then dia akan reach balik dekat time 0, which is A dia akan balik ke CA0. Alright, so that's why dia tak ada CB dah, CB dah kosong dah. CB tu dah kira macam produk dia dah tak ada lah, dah habis lah, kira CB ni sebenarnya adalah referring to the yang HCOOH tu. Okay, once dia jadi produk, bila dia guna balik, macam tadi lah, dia guna balik yang ni as a reactant, dia akan jadi kosong lah. Macam tu dah dia punya konsep. Okay, cuma ingat je satu example ni, you akan faham sebenarnya apa proses yang berlaku. Okay, so daripada sini, kita tahulah which is CA is equal to CA0, 1 minus X. Okay, then we have a CA0, sepatutnya CA0 minus CA0 X. Okay, so CA0 X is equal to CA0 over minus CA. So inilah sebenarnya benda alah ni. Okay, so at different X, dia akan bagi different value of this one. Okay, so ingatkan ini adalah TCSR adalah semua benda ni, and TPFR adalah bawah ni. Okay, tapi kalau you tengok untuk ni dia mewakili macam ni. Terbalik dia pula. Dia terbalik dengan TCSTR ni lah, tahu CSTR ni. Okay, so this is A is equal to R sepatutnya. Okay, tapi kita jadikan dia ini sebagai reactant juga, dan on the same time dia akan jadi produk juga. Okay, that's why dia the whole equation would be like this one. Okay, so negative RE is equal to dCA over dt. Okay, is equal to KCA CR. Okay, we have a dengan R lah macam ni, ibarat macam ni. Okay, so R ni dekat sini juga sebenarnya. Okay, that's why dia ada reactant as a reactant here. Okay, so given that the total concentration is equals to, okay, C naught ni akan ada CA plus with the CR, okay, which equals to dekat at time 0, which is CA naught plus with the CR naught, okay, sebab dia akan jadi constant at the end. Ingat tak graf yang tadi, which is graf macam ni. Okay, alright. Okay, so rearrangekan dia. Okay, for example, we have F in F naught is equal to FA plus with the FR. Okay, so So C0 is equal to CA plus with the CR. Okay, so daripada sini rearrangekan dia, letak CR dalam satu tempat. So CR is equal to, masukkan lah C0 minus CA. So masukkan balik CR ni dalam sini. Okay, that's why you akan dapat this one. This one mewakili CR. Okay, catalyst dia lah. Alright. Okay. Okay, sebab selalunya kalau awak tengok adalah negative RA is equal to dCA over dt tau. Tapi untuk autocatalytic ni, dia akan jadi special case which is negative dCA over dt. Okay, sebab CA ni dia akan turun balik ke CA0. Okay, alright. So macam biasa kita tengok CA0 dia tak akan jadi CA0 balik, dia akan jadi CA. Okay, tapi yang ni dia akan turun balik ke CA0, that's why dia ada negatif ni. Okay, alright. Okay, so daripada situ sebenarnya kita boleh construct a table. Table pula, a graph. Okay, so contohnya, okay, ini sebenarnya saya tak boleh terangkan lah sebab ini dah dalam calculus. Macam mana daripada tadi, this one, okay, kita buatlah. Kita rearrangekan dia akan jadi negatif dCA, alright, over with, masukkan bawah, which is CA, C0 minus CA is equal to K dt. Okay, ni yang dia nak tunjukkan. Macam ni lah. Alright, so dia rearrangekan dia guna adalah nama dia partial fraction daripada calculus. Okay, dia akan dapat bentuk ni. Okay, so daripada sini kena integrate. Sebab apa? Tadi kan kita ada CA dengan dt kan, so kita boleh integrate in term of CA, kita boleh integrate of the time. Alright, so sebelum kita nak integrate, kita kena keluarkan benda alah ni dulu, becoming like this one. Okay, baru kita integrate. Okay, tapi nak integrate ni dia ada special case lah, dia guna calculus ke whatever kan. So at the end dia akan dapat ni lah. Alright, so equation ni sebenarnya hasil daripada after integration. After integrate benda ni, dapatlah benda alah ni. Alright, dia just nak show, remember kalau daripada integration kita boleh construct a graph, which is this one would become X, this one would become Y. Okay, so kenapa this one boleh jadi macam ni? Because of kita boleh simplify. Remember CR is equal to C0 minus with the CA. Okay, so C0 minus CA ni kita replacekan dengan CR. This one pun kita replace dengan CR. Okay, so automatically this one would become the Y. Okay, so this one CR0 ni CR. Okay, okay, kalau ni CR0 is equal to C0 minus CA0. Okay, so inilah replacekan dengan ni, dengan this one, number 1. This one, number 2, replace kat bawah ni 2. Okay, so disebabkan dia nak rearrangekan, dia naikkan tu dia jadi macam ni lah, dia rearrangekan, jadi perkan dia. Okay, so bila awak construct, this one will be the Y. Okay, and this one ni M kan, so X dia adalah T. Ni X dia lah, tu so you nampak T. Okay, so Y dia yang ni. Okay, so M dia adalah, slope dia adalah equals to C0 times with the K. So inilah slope dia. Okay, so bila you construct the slope, you boleh dapat nilai ni. Okay, so faham ke? Ni last lah. Right. Okay, maybe takkan faham 100% lah, tapi kalau awak tengok balik, try study balik, slide ni I think dia boleh improve lah your understanding. Okay, everyone, are you okay? I tak tahu dah pukul berapa sekarang, sekejap.
Okay Doktor, 11.30 sekarang.
Berapa?
11.33.
Oh, 11.33. Oh, saya ingatkan dah lewat saya. Dengan ada banyak, aduh, banyak iklan lah apalah tadi. Okay, so saya dah upload dah, apa nama ni, sebenarnya saya dah set dah assignment 1, cuma sekarang kat course coordinator dia kena vet dulu soalan tu. Jadi ni saya tengah tunggu course coordinator tu untuk bagi balik assignment 1 saya, baru saya boleh distribute kat you all. Okay, so tunggu dulu lah. Tapi don't worry, saya akan bagi gap macam 4 weeks lah untuk you siapkan. Okay, 4 or 5 weeks, tengok macam mana. Maybe 4 kot. Sebab kalau saya lambat sangat pun nanti saya tak sempat nak marking and bagi you marks dia lah. Okay, so better macam 4 minggu dah okay kot, saya bagi awak masa sebulan nanti awak settlekan assignment 1 tu. Okay, so ini saya dah upload dalam Teams. Okay, so try buat apa yang mampu dulu. Okay, so kalau tak sempat siap, buat during the tutorial session. Okay, so nanti hari Khamis ada tutorial. Saya akan discuss berdasarkan apa yang kamu tanya saja. Macam tu lah. So daripada situ awak boleh tackle lah apa sebenarnya awak tak faham, dan saya pun boleh tahu mana satu yang ada gap of understanding tu kat part mana. Okay, faham ke?
Faham, Doktor.
Faham, Doktor.
Madam.
Okay, nak tanya apa-apa ke sebelum saya habis? Kan? Ada apa-apa ke nak tanya?
Saya tak ada.
Oh, tak ada. Oh, Amir tak ada. Okay. Alright. Okay. So itu sahajalah. Nanti apa-apa update saya akan bagi tahu kat WhatsApp lah. So kita jumpa hari Khamis, dan saya minta maaf lah hari ni banyak interruption. Saya banyak kena pause sebab anak saya sakit perut lah, apalah, whatever lah tu. Terus saya buat apalah tadi. So itulah.